Welcome to video 1.2 of our section on scraping with Selenium. This video is called What Makes Up a Website. In order to scrape data from a website, we have to first understand what makes up a website and how data on a website is organized. Once we know this, we can tell our script the location of the data we're interested in so that it can grab it for us. So in this section, we're going to talk on a high level about how a website is organized. And then we're going to kind of go into the details of HTML tags and attributes and CSS classes and selectors. And then we're going to do a short demonstration building a website, which is really going to reinforce our understanding of these concepts and make web scraping a lot more intuitive and straightforward in the future. I see a lot of Selenium scripts that people write, and it's clear that they haven't taken the time to learn how a website is organized, and their scripts are slow and bulky and they're prone to bugs. So this is very valuable information. A web page is made up of three core elements: HTML, CSS, and JavaScript. HTML is mostly in charge of the content and the structure of the website, like all the text and the images and the different parts of a page. CSS is in charge of the style of a website and the layout of a website, such as colors and fonts and what content is next to or over top of what. And finally, JavaScript is in charge of the interactivity of a web page. So things like pop-ups and timeouts and reactions to clicks and mouse movements and so on are often dictated by JavaScript. This is a good overview, but in reality the functionality of these different languages can overlap somewhat. For instance, both CSS and JavaScript can be used to create animations. Both CSS and HTML can be used to enforce page layout. And interactivity can be achieved with a different kind of language called server-side languages. And these include C# and PHP and Python, and we'll discuss those later. As I said, HTML makes up the content of a web page. And these are structured into tags, where you have an opening tag, then the content inside, and then a closing tag. Some common tags are P for paragraph, A for anchor, which is usually used as a link, div for page division, li for a list item, or td for table data. There are over 100 of these tags, and you can see a comprehensive list at this link. Tags can have attributes, which are also called properties. These specify more information about the tag other than its content. They're structured like so. So you have the opening tag, then the attribute name, equals, and then in quotes the attribute value. Different tags can have different attributes. For instance, an input tag can have an attribute which specifies whether it's a date or a password or a plain text or just a check mark, and so on. The most common attributes a tag will have are a class and an ID. That leads us to CSS. Recall that CSS defines the style of a web page. Classes are used to assign a common style to a bunch of different tags, whereas since IDs are unique to a tag, they are used to assign a style to one particular tag. You assign styles to different tags using something called CSS selectors. So if you're assigning a style to a tag, you just write the tag name. If you're assigning a style to a class, you'll prepend it with a dot. And if you're assigning a style to an ID, you'll prepend it with a hashtag or a pound symbol. The helpful thing about classes when web scraping isn't that they identify common styles, it's that we can use them to locate the data we want. If they're repeating tags containing the data we want, we can be fairly confident that they will have a common class. Recall that JavaScript is the interactivity of a web page, and it responds to events. It uses CSS selectors to interact with specific tags. So for instance, if you press a button, JavaScript knows which button you pressed by that tag's ID. JavaScript is also a client-side language, meaning it runs in the browser. We'll discuss server-side languages later. It's also very, very helpful for us when we're building and debugging our Python scripts. We'll see that in a future video. So now we're going to do a demo using HTML, CSS, and JavaScript together to build a web page. This will reinforce our understanding of these concepts, and we'll see examples identifying specific pieces of data using CSS queries. As I said, a website is made of three core elements: HTML, CSS, and JavaScript. So this is a program that's going to let me build a website by writing code for each of these individually. Let's start by creating a website with just 3 paragraphs. So here's the website there. The 3 paragraphs The first says, welcome to my website, and then the second two are facts about me. So I can set the style for all of these paragraphs using the CSS selector of just the tag's name. In that case, it's P. So then we can say the font is going to be Arial. And you can see that takes effect on all of the paragraphs. But you can see this website is kind of crummy because the first paragraph is meant to stand out. It's meant to be different from the other two paragraphs. So let's give it an ID. We'll call it title. Now we can say that in the CSS, any tag with the ID title should be in red. And we can say that it should be aligned in the center. And you can see that affects only the tag with the ID title. But now let's say I want to assign a style to the two other paragraphs. Well, I can't just use this P tag because that's going to affect all of the paragraphs, including the title. So let's give those two paragraphs a class. We'll call it info. Now I can set all the tags of the class info to have a font size that's small. And you can see that only takes effect on those two info paragraphs. So this is a very basic example, just using the tag name, the ID, and the class as our selectors. Now keep in mind that right now I'm using these selectors to assign styles, and that's how they're built on websites. But we're going to be using the exact same selectors to identify specific tags containing the data we want to scrape. So let's now look at an example of how data is going to be organized on a website that you might want to scrape. So here we have two unordered lists, one of which has an unordered list nested within it. Let's say you want all the data. You want the data in each list item, so A, B, C, D, E, and F. Well, you can simply use the selector LI because that's going to select all list items. And you can see that highlights all the list items red, so you can see that that's selecting everything. But perhaps that's not what you want. Let's say rather you want only the first list. You want only the items in the first list. Well, you can see that that list has a class foo. And so we can use that in our query. And we can say .foo and then put a space. And that'll specify we only want the list items within the class foo. Now all tags within a tag are said to be that tag's descendants. So you can see it's selecting A, B, C, and D because those are all descendants of the class foo. Okay, but you can see that that's included both the list A, B, and then the sublist C, D. Maybe you only wanted A, B. Maybe you only want the tags nested immediately within foo. Well, those tags are said to be the main tag's children. So all tags within a tag are descendants, but descendants that are only one level removed, their immediate descendants, are children. Well, to specify children, we can use this character. And now you can see immediately we're only selecting A and B, not C and D, because C and D aren't foo's children. So this is the sort of terminology you'll see. You can refer to a tag's child or parent or grandchild, or a tag next to it on the same level is a sibling. So anyway, to specify only children, use this arrow character. But again, let's say we wanted to be even more precise. Let's say we only wanted every other list item in a list. Well, these queries can start to get complicated, and they're quite powerful. So now we can say we want the nth child, we only want the evens. And you can see now we're only selecting B, because B is the only even list that's immediately a child of foo. But if we get rid of the child selector, you can see we're selecting D and B, because those are every other. And if we get rid of foo, we can see that we're selecting every other list item completely. And so you'll start to gain familiarity with these query selectors, and they'll let you index in razor-sharp accuracy exactly the data you want. There's far too many variations of CSS selectors for us to cover in this video, but after viewing examples online and looking at the documentation as you run into problems, you'll begin to gain a familiarity with them. And I hope you're starting to get an idea now of why we're investing in learning about these selectors. Now that we know how a website is structured, and we know how to use CSS queries to select specific pieces of data, in the next video, we'll talk about how to interact with a website and get the data from it that we want.